Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem-solving skill. In this video tutorial, we will discuss a multiple choice question with only one correct option on pure rolling motion of a circular disc on an inclined plane. The question is as follows. An inclined plane of height h makes an angle 60 degrees with the horizontal as shown in the figure. A disc is rolling down the inclined plane without slipping. Then the linear acceleration of the center of the disc is. The options are g by 2, g by root 3, g by 3 and 3g by 4. Before proceeding to solve the problem, let us recall the related concepts, which are as follows. Let mass of the disk is equal to m and radius is equal to r. Then moment of inertia of the disk about an axis passing through its center and perpendicular to its plane is given by I is equal to half mr square. If the radius of gyration is equal to k, then moment of inertia I is equal to mk square. From equations 1 and 2 we get k square is equal to r square by 2, which implies k square by r square is equal to 1 by 2. Let the final angular velocity of the disk is equal to omega and linear velocity is equal to v. Therefore, kinetic energy of translation is given by kT is equal to half mv square and kinetic energy of rotation is given by kr is equal to half I omega square, which is equal to half mv square into k square by r square. Now for the answer. From equations 4 and 5 we get the total kinetic energy of the disk K is equal to kT plus kr. Putting the values we get K is equal to half mv square into 1 plus k square by r square. Putting k square by r square is equal to 1 by 2 we get k is equal to half mv square into 3 by 2. Now decrease in height of the disk from A to C is equal to h. Therefore, loss in gravitational potential energy is equal to mgh. From equations 6 and 7 we get half mv square into 3 by 2 is equal to mgh, which implies v square is equal to 4 by 3 into gh. Now let us consider the linear motion of the center of the disk from A to C. For this, initial velocity is equal to 0 final velocity is equal to v, displacement AC is equal to s, let the required acceleration is equal to a. Using the kinematic equation v square minus u square is equal to 2as, we get v square is equal to 2as. Now, from equations 8 and 9, we get 4 by 3 GH is equal to 2as, which is equal to 2a into h by sine 60. Here, we have used the relation h by s is equal to sine 60, which implies a is equal to 2 by 3 into g into sine 60, which is equal to 2g by 3 into root 3 by 2, which gives a is equal to g by root 3, which is the answer to the question. Therefore, the correct option is B. This completes the answer to the question. Thanks for watching. If the video is helpful, then please like, share and subscribe.